Welcome, everyone. Thank you for joining us today. This is the sixth webinar that we're offering this summer in our EHS Educational Webinar Series. Today's topic is chemical process safety, best practices and regulatory challenges. And my colleague, Frank Rooney from EnSafe is going to be giving the presentation today. Frank is a certified industrial hygienist, and he also serves as our process safety management service line lead for EnSafe. And for those, similar to how we've handled the previous webinars, if you have questions, I would ask you to kindly use the Q&A feature at the bottom of your screen. Please type your question there, and at the end of the presentation, we'll run through all of the questions and offer answers to those as best we can. So with that, Frank, I'm going to turn it over to you.
Well, thank you, Leo. Thanks, everybody, for participating. The topic today is around process safety, and I'm going to talk a little bit about the Process Safety Management Standard and the EPA RMP program as well, but I really want to highlight the idea that you don't need to be covered by the standard to get the benefits of doing some of the elements of the standard, and that's kind of the gist of what I'm going to talk about today. So let me share my screen. I'll start with some slides for you and show you what we're going to have here. Chemical process safety. You know, it's one of those things that, as I mentioned, that when things are going well, everything's all right. But as we know, things can go dramatically wrong if your process is a little out of whack or something unforeseen happens. And so I'm going to kind of talk about that today in relation to some of the standards that are out there, and just use a case study to kind of highlight why this is important to many facilities, even if they're not covered under PSM or RMP. So really I want to get to is that chemical process safety concepts can be successfully applied apart from regulatory compliance. You don't need to be under the standard to have some benefit for understanding this. OSHA's PSM standard is not just for large complex processes. It applies to those large complex processes, but quite honestly, there's lots to be gained by applying some of the elements to smaller processes. And like I mentioned at the last, PSM concepts should be used as a risk management tool. It's a way to manage your risk as a plant manager, as an EHS professional at your site. So let's start at the beginning. Why chemical process safety management? And if many of you can recall, back in 1984, there was a kind of an eye-opening event that occurred in India where many people were killed due to a chemical incident. This is the Bhopal incident that occurred due to a failure of a variety of things at a plant. And the issue there was that many of the folks who passed away or were killed were not employees. They were people living outside the fence line. And you can see about 2,800 people died. Other estimates put the death toll as high as 8,000 because these are very poor people, and the method of counting the bodies was not exact. The bottom line was that this is a tremendous worldwide disaster that woke up a lot of people to the whole idea of chemical safety. If you recall, the company that was involved was Union Carbide. Union Carbide has since gone out of business, much in relation to this incident. But Dow Chemical still owns the Union Carbide trade name, and if you go to Dow Chemical, you can read still about Bhopal. They still have some information on their webpage about the history of this because it etched such a permanent mark in people's minds. And you can read some of the information around the whole incident and that kind of thing. But this is kind of what opened up people's eyes back in 1984 to the real threat of a chemical plant being nearby. But it's not where chemical process safety started. You can go back to the 50s, and probably even quite honestly before then, to loss prevention concepts, basic process safety management principles developed through like the American Institute of Chemical Engineering, the introduction of human factors in the 70s, which was really probably a result of the space program. And then the first industry consensus PSM standards started coming out in the 1980s. And these were consensus standards, not regulations, promulgated by folks in, the American Institute of Chemical Engineering and some other engineering aspects. And again, a lot of this really, if you look back in the 60s, what was going on was that this was the heyday for plastics manufacturing. And plastics manufacturing used a lot of organic material, a lot of flammable materials. Then people started realizing that, hey, we got to really think very clearly about how we manage these things safely. And like I said, from the space program, there's a lot of work done on human factors, the interaction of people with these processes and where errors could occur. And then, standards evolve from that. Next on the scene becomes OSHA. Now, OSHA proposed their process safety management standard in 1990. That was through the Clean Air Act Amendment. Quite honestly, the Clean Air Act Amendment was amended, and it required EPA and OSHA to work together to create a process safety management system, if you will. And so the PSM regulation for OSHA appeared in 1992, and it coordinated with the EPA Risk Management Plan standard in a similar time frame. What's interesting about these two standards is that they overlap tremendously. They have lots of commonality to the two of them. However, they come at it from two different directions. Obviously, OSHA's mandate is to protect employees, and so they have a very occupational bent on their standard. And the focus of their standard, obviously, is to reduce the risk of injury to employees working in and around chemical processes. The EPA's focus was more on the environment and what goes on beyond the fence line. And so their standard really deals with what happens if you have a catastrophic release that leaves the site. What happens to the downstream, what are the downstream consequences of that to not only people living nearby, but also to the environment near the plant. So both standards, even though they're really addressing the same thing, came from different angles, and both of them apply in many cases. There are some nuances where one will apply and one will not, but for the most part, they do overlap quite a bit. So a little bit more about OSHA and the process safety management standard. To have the standard apply, you really have to have one of the 137 listed highly hazardous chemicals, and you can find that listing as Appendix A to the standard. OSHA standard is 1910-119. Appendix A has that listing of 137 highly hazardous chemicals, and it matches up pretty well with what the EPA also considers a highly hazardous chemical. Most of the material in there, for the most part, the threshold quantities are measured typically in thousands of pounds. And most of the threshold quantities, have to be pretty high for them to be considered very risky. However, some material there you don't need a lot of. For example, if you were in the semiconductor industry, and I used to work there, diborane and arsine, which are two gases that are used in semiconductors, the threshold quantity is only 100 pounds. And quite honestly, there's lots of facilities out there that are making, integrated circuits these days that have well over 100 pounds of diborane and arsine on site. So it doesn't always mean that you have to have a lot of material in order to have the PSM standard cover you. What it means, though, is that you have a highly hazardous material on site that meets the threshold quantity. The other thing about the OSHA standard is it does cover flammable liquids and gases connected to a process when you have more than 10,000 pounds of them. And the key word there is connected to a process. If you're storing 10,000 pounds of fuel oil on site to fill your diesel trucks, that really doesn't count. That's not a process. However, if you're using that diesel fuel and you're modifying it in some manner or adding something to it and then sending it off as another material, then yes, it does cover that. So the key is that it has to be part of a process. Unlike EPA, OSHA does cover flammable liquids and gases when they're greater than 10,000 pounds. EPA RMP does not cover this aspect of it. RMP really only focuses on the 137 listed highly hazardous chemicals. So another example, why PSM? So think back, you have Bhopal, it happened in 1984. The standard got promulgated in 1992, And here is 2005. We had a massive explosion at a BP American refinery down in Texas City, Texas, that killed a lot of people. So the point of that is that just because you have a regulation in place doesn't mean that the problems go away. In this case, the issue really was related to contractors. In this particular instance, they had created a laydown yard right adjacent to their distillation tower. And there was many contractors in contractor sheds along with other pieces of equipment nearby that essentially got caught up when this distillation tower flooded with hydrocarbons, overpressurized, and essentially exploded. And that was where most of the people were killed during that initial explosion. But again, this was 13 years after the promulgation of the PSM standard. So again, having a standard doesn't always mean everything's going to work out well. So process safety management, this is what many people's minds go to when they hear that phrase. It can be daunting. There's lots of aspects to process safety management. There's a lot of things to consider. And I think what ends up happening is that many practitioners get intimidated by it and would rather not have to worry about it because it is kind of a big standard. It's rather intense. It's very engineering focused. And because of that, it can get very, very detailed and confusing in a hurry. And so process safety management a lot of times turns people off. They really don't want to have to deal with it. It's not straightforward, and it's something that confuses them. But I'm here to tell you that there's many things to learn from process safety management, and quite honestly, it doesn't have to be scary. PSM does not have to frighten you off, at least most of the time. I think there's many things to learn from process safety management that would be a real benefit to most people. So what is process safety management? Well, it's really a framework, much like many of our standards out there that are ISO standards. It's a framework by which you manage your risk. In the case of process safety management, the OSHA standard has 14 elements to it, and I'll take you through a little of these in a minute, but they all play a key role in creating this management system that oversees your chemical processes. And the goal for at least OSHA is employee protection. Obviously, the goal for EPA is environmental protection and protection for the general community. But in both cases, they rely on the same 14 elements to carry that duty out. So let's talk about some of those items. And I won't go into great detail on this, but there are some that are very unique to this standard that you don't see in many other OSHA standards. First one being employee participation. OSHA mandates that you have a written employee participation program that demonstrates how employees participate in determining process safety management requirements. With the key element there being is that they want the employees to be the operators. They want, because, and rightly so, the operators tend to be the experts of the process. Certainly engineers and some of the management, well, they understand the process very well, but it's the operators who are turning valves, opening and closing vessels during the week, making sure that things run properly. They're the ones who really understand how things work. And so that's why OSHA really is keen on making sure that employees participate in many of the elements of process safety management. Another area that is only one line on here called process safety information, but quite honestly, it's a very big area of process safety, and that is all of the information associated with your process. And by that, I don't mean just the SDS, but that is key because it will tell you the chemical and physical properties of the materials you're dealing with. But this also includes things like the parameters of your process. What temperatures do you run at? What's your intended flow? How much material do you want to keep on site? How much pressure is there in the system? And more importantly, what happens when you don't have those parameters in place? What happens if you get outside the bounds? Do you have safety systems that will protect you and keep you within the bounds of the safe process parameters? And if that doesn't happen, what do you have to minimize the hazards? For example, do you have a fire suppression system? Do you have interlocks? Do you have alarms? All those things are all included in what's called process safety information. So even though it's one of the 14 elements, it makes up the majority of the information you as a process owner need to gather and retain. The other one I want to highlight is process hazard analysis. A process hazard analysis is just that. It is a disciplined methodology for looking through a process and figuring out where your hazards are, and from the hazards, what kind of controls do I have, and what's the likelihood of those controls failing, and what's the potential outcome of something goes wrong. Process hazard analyses, again, they're required for process safety management, the process safety management standard, but they serve a lot of other purposes, and I think the process hazard analysis could be performed on many different processes. So, for example, if you have a refrigeration system using anhydrous ammonia, the OSHA process safety management standard doesn't apply unless you have over 10,000 pounds of ammonia in your process. Well, I've been to many facilities where that's a 5,000 pound system. And so just because it's under 10,000 pounds doesn't mean it can be ignored. And by applying some of these process safety management elements, even to a 5,000 pound ammonia system, will be a great benefit to those working around it, because that will really minimize the risk of having a release. And a release of 5,000 pounds is still a significant release, even though it's not under PSM or, in this case, either RMP. Some of the other aspects include training. There's a specific element for contractors, not only on how you handle the safety of contractors, but it really gets right down to the vetting and the management of contractors. Going back to that Texas refinery explosion and other issues that have happened in oil and gas, contractors tend to be involved in many of them. Sometimes they are involved because they are the cause, and that's because maybe the contractor did something wrong and upset the process. Maybe they opened the valve they weren't supposed to. Maybe they were doing hot work in an area that they weren't supposed to be doing, and that caused the problem. On the other hand, especially in oil and gas, you have many contractors and sometimes even more contractors working on site than you have actual employees. And so you need to understand how to manage those folks, because not only are they critical to keeping your process up and running, but also it may be the most likely population that could be adversely affected by a catastrophic release. So contractors are also another area. Some of the other areas, mechanical integrity, hot work, management of change, are always important. And I'm not going to go through all of them, but just to know that there are many elements here that can apply, and you don't need to be under PSM to find the benefit of some of these by going into and looking at them. So, is there value in the PSM regulation beyond compliance? And I'd say absolutely. Again, there are a lot of companies out there who feel intimidated by PSM, purposely try to be below the threshold quantity, no matter what they are using, just so the PSM won't apply. But quite honestly, I think they are missing something that's very valuable, and that you can learn a lot and can protect yourself a lot by implementing some of the PSM elements, even if you don't have to do it in full because you're not under the PSM standard. I like case studies, and so I wanted to take you through this one. This is essentially something that could happen, I think, to many different companies out there. This is MGP Ingredients Processing in Atchison, Kansas. This happened back in 2016, and essentially is a series of unfortunate events, and it leads to a bad day. So I'm going to take you through some of this and show you a little video from the Chemical Safety Board, which kind of gets in some of the details of this. But this is just an interesting scenario, because it is something that I think could happen at many sites, and certainly many of the clients that I've been to that aren't even PSM. This could definitely happen. By the way, these are photos of the adverse event that occurred. So that is a chlorine gas cloud that is wafting over the little city of Atchison, Kansas on that particular day. So to preface this a little bit, this is really related to chemical filling of tanks. So again, according to the National Association of Chemical Distributors, in 2016, more than 39.9 million tons of product were delivered to customers every 8.4 seconds. That is a lot of chemicals that are being delivered all day long, every day, to a variety of plants, probably your plant. Most of these are delivered by tanker truck. They could also come by rail car. But the bottom line is that there's millions of pounds of material that are going from one vessel to another every day that, quite honestly, could result in a catastrophic event. And that's exactly what happened in Atchison, Kansas. So a little bit of background. MGP Ingredients in Atchison, Kansas employs about 140 personnel. You know, I would call that a mid-sized manufacturing plant. They create food-grade alcohol and corn products and are a contract manufacturer of premium distilled spirits. So like many companies in the Midwest, they were processing corn and turning it into alcohol, okay, and food-grade alcohol. So it was going to distilleries, and they were probably using it for other items in the food processing business. But not a very big plant, 140 personnel. Some other things. There were OSAS 18001 and ISO 14001. Again, those are badges of honor that we all try to get for some of our facilities. They were certified since 2009, and this incident occurred in 2016. So they had been certified for a number of years. Obviously, they had management systems in place, so they probably wouldn't have gotten certified. So they were a pretty well, managed employer. They're a public company since 1988. And you can kind of see the layout of their processing plant here. The main plant, you can see in the upper left there, is a lot of distillation columns and other processing facilities. You can see the railroad tracks that kind of cut across. You can see the wastewater treatment plant in blue, and Mod B, which is where their incident occurred. That is really their little tank farm where they receive chemicals. And Gasoline Alley is the route by which the trucks would drive down to Mod B to offload. So you can kind of see, again, not very big footprint. You can see it's right on Main Street in Atchison, Kansas. So my guess is probably one of the premier employers in that area, and very prominent. So what happened? Well, back in October of 2016, 7:30 in the morning, all right, a delivery of sulfuric acid. Pretty standard stuff. Routine delivery by Harcos Chemical. Harcos was their supplier. They also supplied sodium hydroxide and propylene oxide to the plant. And the driver had made 6 previous sulfuric acid deliveries to the site in 2016. So this is not like his first rodeo. This guy had been there 6 times through the course of October, so probably about every 6 weeks or so, he would come by and deliver sulfuric acid to this plant. And so this is a regular, relatively routine event as the plant goes. Well, what ended up happening in this particular day is that they had a cross connection. They connected the sulfuric acid offload truck to the sodium hypochlorite tank. Sodium hypochlorite is better known as bleach, okay? And they had a bleach tank there. And the person connected the wrong hose to the wrong fill line and resulted in an incompatible chemical reaction that emitted chlorine, chlorine dioxide, and hydrogen chlorine gas, okay? Pretty nasty. You see in this picture, you can see that is the actual plume as cutting across the Main Street there back in the day of in 2016. So what ended up happening? Well, the good news is no fatalities. However, 4 MGPI employees, the Harcos driver, and 140 people in the community all sought medical attention. 11,000 residents were advised to shelter in place, and 800 middle and high school students had to evacuate because they're downstream of the plume. So the good news is that no one was seriously hurt. Bad news is that it affected the entire community. And again, what's interesting to note is that neither the PSM nor the RMP standard applied to this facility. The amount of material they had on site and these 2 particular chemicals did not exceed the threshold. And quite honestly, it was well under the radar of OSHA or EPA for this particular instance. So that's just a picture of it from above, from the helicopter. You can see that plume is quite large. And that is a very toxic cloud that's going across the town during that morning. So a little bit about the investigation. This is a picture from the Chemical Safety Board review. And you can see this was the connection manifold where the driver would then connect his truck up to the fill lines. You can see how the fill lines are labeled in this picture. In real life, those labels are not there. Those fill lines are not labeled. The only thing that may have a little label on it, if you look to the far right, the propylene oxide, you can see PO line written on the piping there. Other than that, none of those fill ports are labeled. And what's also interesting is they're all identical in terms of size and shape. So there's no difference in terms of what you could connect to it. One size fits all. The other interesting fact is that the sodium hypochlorite fill line was 18 inches away from the sulfuric fill line. And those are incompatible materials, sulfuric acid being an acid, sodium hypochlorite being bleach. We all know from mixing chemicals at home that you don't want to mix an acid with a bleach. Causes all sorts of problems, and that's exactly what happened here. Again, this is something that is relatively simple and straightforward, yet caused a massive problem in Atchison that day. So what I'd like to do is show you a quick video here. I'm going to show you a few minutes of the video that the Chemical Safety Board put together so that you can understand how this played out for them. And I think the animation is really well done. So let me run this for you.
October 21st, 2016. The MGPI processing facility in Atchison, Kansas. An unintended chemical reaction resulted in a dense cloud containing toxic chlorine gas and other chemicals that drifted into the community, leaving over 140 people with reported injuries. The incident occurred during a routine chemical delivery when two incompatible chemicals, sulfuric acid and sodium hypochlorite, were inadvertently mixed, forming the toxic cloud.
Delivery and unloading operations may be perceived as simple compared to other processes at chemical facilities. But because these activities can involve large quantities of chemicals, the consequences of an incident can be severe. Our case study on the MGPI incident stresses that facilities must pay careful attention to the design and operation of chemical transfer equipment to prevent similar incidents.
The MGPI facility produces distilled spirits, specialty wheat proteins, and starches. The incident occurred in a section of the plant that uses sodium hypochlorite, or bleach, as well as sulfuric acid. These two chemicals, when combined, can form chlorine gas and other chemical compounds. On the morning of the incident, a truck from a chemical distribution company, Harcross Chemicals, arrived at MGPI to complete a routine delivery of sulfuric acid. After reviewing paperwork in the control room, an MGPI facility operator escorted the driver to a locked loading area. There, chemicals are transferred from trucks into the facility through piping, called fill lines, to several large storage tanks in an outdoor tank farm. The MGPI operator unlocked the sulfuric acid fill line for the driver to connect the truck's unloading hose. The operator remembers pointing out the correct fill line to the driver before he returned to his workstation. The driver, however, does not recall hearing the operator identify the fill line. Unknown to the operator, the sodium hypochlorite fill line was also unlocked, and the two lines, which were only 18 inches apart, looked similar and were not clearly marked. The driver connected his truck's sulfuric acid hose to the sodium hypochlorite line, and sulfuric acid began flowing inside. He then returned to the cab of his truck. Shortly before 8 a.m., a greenish-yellow gas began flowing from the bulk tank of sodium hypochlorite. The driver noticed the cloud in his truck's side view mirror and attempted to return to the connection area to turn off the flow of sulfuric acid, but the gas overwhelmed him. He then ran to the passenger side of the truck to close a valve that could halt the flow, but he was prevented from doing so by the gas. Instead, he ran away from the cloud and escaped to a separate area of the facility. At about the same time, toxic gases entered the facility control room through the building's ventilation system. MGPI operators preparing for shift change in the control room were immediately overcome by the toxic gas. Because the operators had a practice of locking respirators between shifts, some were unable to access their respirators before evacuating the building. with no other way to stop the flow other than closing manual valves on the fill line or truck, or by triggering one of the truck's emergency shutoffs. The sulfuric acid continued to enter the sodium hypochlorite tank for nearly 45 minutes until emergency responders shut down the flow. Approximately 4,000 gallons of sulfuric acid combined with 5,800 gallons of sodium hypochlorite, causing a large, dense cloud containing chlorine gas, which soon drifted off-site. MGPI employees were evacuated from the site, and 11,000 Atchison citizens were advised to either shelter in place or evacuate. Over 140 people, including MGPI employees, emergency responders, the truck driver, and members of the public, sought medical attention, some requiring hospitalization.
Chemical distribution takes place on a massive scale in the United States. According to a study by the National Association of Chemical Distributors, more than 39.9 million tons of product were delivered to customers every 8.4 seconds in 2016. The CSB is concerned that there are many opportunities for incidents like the one at MGPI to occur.
Alrighty. And you can see more of that video, by the way, if you want to go to the CSB website. They have all their videos teed up there. And they're very good. The animations are very good. So I would encourage you to go see the rest of that video. But that kind of set it up as essentially what I talked about, but a little bit about some of the background as well. So let's continue on with, PSM as a risk management tool. How do we use the process safety management standard, even when it doesn't apply to us, as a risk management tool? And so I kind of broke it down to these steps. You identify the hazards. You prioritize the risk. You figure out your layers of protection analysis. I'll go through each of these in a little more detail. You develop a prioritized risk management plan, then you implement your plan. And so if you're to follow this, even if it, PSM doesn't apply to you, this is a way to better manage maybe the risk at your site, even from smaller amounts of chemicals than would be under the PSM standard. So, process safety information. What chemicals and processes are on site? What can you do? Now, for the purposes of our webinar, I actually created a little checklist or a little sheet that we'll be sending out to all the participants. So you can kind of go through your plan. I've noted some of the common chemicals that many plants would maybe find on their site in sufficient quantity that would be somewhat hazardous. And so I would encourage you to send that to folks at your plant, or you can use that as your own means to go out and kind of check and see what we got. Whether it's a flammable, whether it's an acid, whether it's a base, maybe you got some solvents stored there, whatever it happens to be. The first thing you got to do is you got to figure out what you have. And then once you figure out what you have, you got to look at what the safety data sheet says about its chemical and physical properties. And how is it managed on site? Is it part of your process, or do you just have it stored on site, that kind of thing? And the key is, in this particular case, incompatibles and reactives, but also flammables are very key. So, you really want to figure out what is the hazard associated with the material that we have on site. The next step is to do a process hazard analysis. Like I said, this is essentially interdisciplinary effort. Usually involves not only the engineers, but also certainly the operators, probably maintenance, someone from environment, health, and safety, maybe someone from management, someone from facilities, to kind of look through in a disciplined manner all the elements of your process, how this material is managed by you. And it may be something that's very simple. I've been to some facilities where they use a solvent as a means to, almost as a catalyst. It's not even consumed by the process, but because it's a solvent, it's a very flammable solvent, they have to look at the process hazards to determine how best to prevent it from having a release and subsequent fire. Other processes, you're actually taking chemical A and mixing it with chemical B and creating chemical C. But in any event, all these things are something that you can look at from a process hazard analysis to try to figure out everywhere from the unloading portion, which is what happened in Kansas, all the way to where you're taking your final product and shipping it off-site. And you break your process down to various what's called nodes, which are discrete elements in your process. And then in each node, you kind of figure out what's going on. We typically like to use a hazard operability matrix that we use to assess that, and that really looks at the parameters of the process. So the temperatures, the flows, the pressures, the volumes, and look at it in each element or each section of your process, each node, and determine, what could go wrong. What could happen if this process were to fail at this point and material was released? What material could be released? How much? And we assess at that point, what's the severity of the hazard? What could possibly happen? Could it result in a large-scale fire, or is it simply just a leak that can easily be managed? And we'll rate that in a quantitative manner, usually giving it a severity rating. Then we'll look at the likelihood of it occurring. Knowing that we have certain safeguards in place, what's the likelihood of having a failure at a particular point in the process? And we take those two elements of severity and likelihood and come up with an overall risk score. And then we look at that and we kind of prioritize the risk scores to say, okay, which are the highest risks associated with all the nodes in this process? And that helps drive the decision making about where to invest in this process. Where do we want to spend our money to reduce the risk of this process? That's really what a PHA is looking at. If you're part of PSM, you're obligated to do one every 5 years. If you're not part of PSM, I would certainly say you should do at least an initial one and revisit it every once in a while, especially if you have a change that goes along. PHAs at a minimum are good for about every 5 years. Under PSM standard, they have to be revalidated every 5 years. But there's really a lot to be benefited from doing a PHA. One of the main reasons a PHA is very good is because as the process matures, things change. And the PHA is a good way to assess what the outcome of those changes have been. If you've changed the process along a period of 5 years, you reassess it 5 years later, you may find that things have gotten better, or in some cases you may have some unintended consequences that have occurred because of a change you've made. The PHA is the mechanism by which you can catch that. Once you've done your PHA, like I said, you do your risk assessment, you look at the severity, the likelihood, and you've got to look at your current controls. What do you have in place that is keeping this process from getting out of control? Are they engineering controls or are they work practices? And there's a big difference there. I've been to some plants where their main control on a process is they have their 30-year operator do it because that person is the most skilled and he or she is the least likely to make a mistake. If that's what you're relying on to keep your process under control, you're probably not really thinking well about what's going on with your process. You really want to think of other engineering controls, things that are a little bit more automatic, things that are ingrained in the process so that you don't have to rely on a person doing a task correct every single time in order to protect yourself. You also want to look at maybe some control redundancy and obviously look at your single points of failure. All these things are really part of a layers of protection analysis that can be done. Some layers of protection analysis can get very complex, but for the most part in simple processes is really making sure that you're not just relying on one control to keep your process in check and to keep things from going south on you, that you have a variety of ways to make sure that if something were to fail, it will fail safely. If somebody were to make a mistake, the mistake will not be catastrophic, those sorts of things. And everybody's probably familiar with this. This is the hierarchy of controls. As I mentioned, if you're relying on administrative controls or PPE as your main line of defense for how you manage your process, then you're probably fooling yourself into thinking how safe that process really is. You really want to be looking at isolation and engineering controls and on up this hierarchy to try to figure out what is the best way to reduce the risk of what we're handling. If you look at the MGP analysis by the Chemical Safety Board, they really looked at this layers of protection as a failure on MGP's part. If you watch the whole video, and you can even surmise it just from the beginning of the video, there's a real reliance on administrative controls. There was a reliance on people doing their job correctly every time. There was a reliance on SOPs being correct and that kind of thing. And they essentially allowed things to deteriorate over time. As we all know, standard operating procedures are great, but not everybody reads them all the time. And also what ends up happening is that people will adapt the process or their procedure to fit what they need to do that day. And that may or may not be always the safest thing to do. And without being checked, there's no balances in there, some bad habits can develop that may actually be very risky. So you got to kind of guard against that. And again, that's where layers of protection analysis come in, because hopefully there's another safeguard there that will protect somebody should they vary off the SOP and do something that was not anticipated, resulting in a failure. So if you look at the MGPI example, one of the things of an administrative control is labeling. Labeling is common, right? A common administrative control. The picture on the left is that's what they had there. As I mentioned, the labels I showed you previously were added in on the drawing, but this is what the tanker truck operator faced when he got there that day. Lots of the same fittings, no visible labels. The only visible labels were upstream, and you can see the hydrochloric acid label had deteriorated quite a bit, and the sodium hypochlorite label was actually upside down only because they wanted to get the direction of flow correct. If that was on the right way, the direction of flow would have been incorrect. So somebody was trying to help out a little bit there, but you can see those are the only two labels that could have given you a clue as to what was going on. You can also see in the other picture on the right, there, you can barely make out the word caustic, which is the sodium hydroxide line. So again, a person, 7:30 in the morning, maybe their first run, and they've been there a few times, may got a little complacent and thought they were connecting to the right valve, but they essentially were not. What's interesting is this picture is from another part of that same plant. So obviously labeling was something that they had thought of. It's just that it was allowed to deteriorate in that tank farm. Again, you got to remember now, this was a ISO 14000 and OSAS 18001 facility. And you would think that with that kind of those badges that they would not have allowed that to happen, but things do happen if you don't check and have a check and balance system. So from that, you want to develop a risk management plan. You want to prioritize your gaps from the PHA. As I mentioned, you're going to find that you're going to have some risks there that you may not want to tolerate, and so you're going to want to prioritize those. You're going to want to focus on your weak links in the layer of protection analysis. Where are we relying on an administrative control or PPE, and that's our only line of defense. You want to identify actions you need to build a safer process, both short and long term. Some of these may be large capital projects, but most times it's somewhat short term. There may be something you can do immediately to reduce the risk, and sometimes it's a combination of both. So you may have a means to say, well, we want to install this engineering control, but in the meantime, we're going to add an additional administrative control before the engineering control gets put in place. And that works out many times very well, depending on how rigorous the administrative control is managed. And then use the PHA and LOPA to justify changes to management. Again, if you were going to change something to the process, it may have unintended consequences downstream later than what you thought. And the PHA and LOPA are ways to catch that so that you can adjust before you have a catastrophic problem. So these are some of the Chemical Safety Board suggestions for NGP. Human factors, interactions with employees and contractors. From the video, you heard that the truck driver did not know which cap was unlocked. The issue there was that what he stated was that as they both walked out to the manifold, the truck driver turned to put on his PPE, and that's when the operator turned and left. And so as the truck driver donned his PPE and turned around, the operator was gone. So the truck driver, rather than going back into the control center and asking a question, just decided to figure it out on his own. The whole fill line proximity issue, identical connections and locks. Again, this comes back a lot. A lot of times those fill lines are locked so that you can't inadvertently connect. But if the same key opens up every lock, that's not a very good control. And so that's something you got to watch out for. The SOPs are not aligned with the work practices. One of the things that the SOPs called for is that only the operator at MGP could open a valve, but the MGP operator said that they let the truck driver open valves because the truck drivers had donned their PPE anyway, and it was probably safer for them to open a valve in case of a failure than the NGPI person. So even though their SOP said that the truck driver was not allowed to open the valves, it had been common practice that the truck drivers were opening the valves. And so again, one more check that was not followed on. Training and active monitoring and automation and remote controls. Obviously, if you want to automate a process, that usually adds a level of complexity, but also a level of safety, and it's something always to consider. But again, you know, you have to weigh that investment with the benefit of doing something like that. And then obviously you want to implement the plan. Once you've done all that and you look through it all, what do you want to do? You want to make sure you have a management of change process. So if you are making changes to your process, you're kind of documenting it, you know what's going on. You want a corrective action tracking process. So if you do make changes based on your process hazard analysis and you want to reduce risk, that you're following up on those items that you want to fix and change. And you want to collaborate with other departments. And again, this is not a one-person decision. This is usually a group of people who have to decide, because in every event, there's always trade-offs. You know, if you make something safer for the operator, it may make it less safe for the maintenance. And if you do something to benefit maintenance, it may make it less reliable for facilities. And so you have to have everybody involved when you're doing things like this, when you're analyzing a process, because there's trade-offs no matter what you do, and all those things have to be considered. And this is the conclusion. If you need our support, you know, feel free to contact us. We do this for a living. So we are well versed in how to handle process safety management and RMP, regulated materials plans. But like I said, this can apply to a lot of other things other than just that's covered by the regulation.
Nice job, Frank. Thank you. We do have a couple questions here. If anybody else has questions, please send them through the Q&A feature, and we'll go through these right now. Our first question says, what if a portion of the stored flammable liquids is used for process less than 10,000 pounds, and a portion is used for building, heating, and utilities? So I'm assuming they have more than 10,000 pounds of a flammable liquid, and less than 10,000 pounds is used if it's used in a process, and less than 10,000 pounds is used for building, heating, and utilities. I guess he's asking, is it a PSM covered process?
I would say it is. And I see you nodding your head too, Leo. It's one of those judgment calls. And what OSHA has said is that if you have your connection, and so your connection is your process, but if you have other material around that process that could adversely impact that process and cause it to have a catastrophic release, then you have to include the entire thing in your assessment of the process safety. So in that particular case, if you have two lines coming from a tank, one that's going to a process and one that's going as to fuel, for example, I believe you would have to include that all as part of your PSM. And so if that, by including it all, if that volume is greater than 10,000 pounds, that would mean you are covered by the PSM standard.
And I would, yeah, I would add, I would encourage you to do a site to do a PSM applicability determination for this, an official applicability, and document that, keep it in your records, whether you learn that it is or is not a PSM covered process. You'll have that documentation in your records.
Yeah, I agree.
Next question regarding training. We are a port authority and we have maintenance crews that perform work on oil docks around process equipment. What kind of training should I provide my employees that work around this equipment?
Well, for those processes that are covered by PSM, OSHA requires operators to be trained every 3 years in the process, in the SOP, to understand what is going on with PSM. That's the most rigorous training that's required. For maintenance employees, it's really one and done. There's no requirement for retraining for maintenance. They have to be initially trained on how to do their job with regard to that particular process, but then they're done. Same with contractors. Contractors working in that process are kind of handled similarly to employees, and so they would have to be trained when they come, and if you're using the same contractors over and over again, it's probably prudent to retrain them every 3 years. And then for those who are not necessarily part of the process, but maybe working around it, they should get some initial training just so they understand what process safety management is, what to avoid. Obviously, there's some controls. If you read into the OSHA standard, you have to control access to the process safety management area. So you want people understanding that, if their job doesn't take them in that area, they should not go in that area, that kind of thing. And really, the best way to do that is through some sort of training or orientation when they come on site, or maybe initial orientation when they're hired. But those are kind of the training requirements that OSHA has. In my view, training is always important. The more people know about what they're dealing with, the more likely they are to handle it correctly. And it really depends on your turnover and what's going on with the folks there. If you have lots of contractors coming and going, you'll probably be training more contractors than employees. But at the very minimum, people who are working in the process need to know what's going on, and OSHA requires them retrained every 3 years. People working around the process, even if they're not touching it, need to know that they're not supposed to enter it, so you have to give them some basic orientation.
Thank you. Next question. Regarding mistake proofing using different regarding mistake proofing using different connection configurations for different chemical fill lines. Are there industry standards for specific types of connections for specific chemicals? And if not, how would one coordinate with the vendor to have the correct equipment on the truck?
Well, that's an interesting statement, because that is one of the recommendations of the Chemical Safety Board, and there is no industry standard that says, okay, sulfuric acid connection has to be, 3¼ inches, and a hydrochloric acid connection has to be 2¼ inches. There is no standard around that. And so you're right, when your supplier arrives, they're not going to have all the connections needed if you've gone and done that. So you really need to work with your chemical suppliers to figure out a way to best engineer in a solution there. And again, in most times you're getting your chemicals from the same supplier, and you can work with them in a partnership, and they can understand what you're trying to achieve. And you may want to change fitting sizes just so that you don't get that cross-connect hazard. But it is not an industry standard. So once that supplier leaves your site and they go to another client down the street, it's not going to apply to them. So you're going to have to partner with them and see if they're willing to go and do that. I think the key, though, is, in this case, we've done it in the past, I've seen it, is labeling and also locking of the caps. As I mentioned, you can do a lot with a cap lock and a lock actually on the cap. So you put the cap on and you have an individual padlock that the key is pretty clear that key is only for that particular chemical. And then obviously you have to have it labeled as an administrative control. That's one way to assure it. The other one is to make sure that your incompatibles are not fed from the same manifold. So you don't have that situation where you have 5 options and some of them are incompatible, and the truck driver gets to pick which one he wants to use. And again, the truck driver in this case, wasn't trying to do something wrong, but he was given 2 options and thought he picked the right one. By not having the labeling there, just as a reminder, was probably a big issue for them. And again, at 7:30 in the morning, who knows, might have been a little dark. He had his PPE on, may not have good visibility, and quite honestly, had some complacency and probably guessed at which one it was and guessed wrong. And that's all it takes is one false move like that. We've done some work for some sites where they have many more chemicals in the manifold like that, and we've made some suggestions around that. Color coding is key. Maybe all your acids you color yellow, maybe all your solvents you color red. There's all sorts of schemes you can try to use to try to minimize the risk of a cross-connect, but unfortunately there's not an industry standard out there.
Our next question, was MGP held more responsible for the vapor cloud? After quickly researching, it looks like both companies were indicted. Is there more responsibility implied with the ISO certification?
That I don't know. I don't know how it all played out in the end. I would assume that MGPI's facility, and they probably bore the brunt of the responsibility. Harco's was the supplier to them, supplied many other companies. So my guess is that probably MGPI probably bore the brunt of responsibility. I don't know if the ISO standard played into it at all. You would think that they'd be given some leeway for having a ISO 14000 and OSAS 18001, but it didn't help them in this case. So not sure how that all played out, but it was their facility, and so my guess is that they bore most of the responsibility.
And our last question, can you briefly discuss the implications of the MIR decision?
You know, it was, that's one of those, it's an interesting decision. For those who don't know, MIR is the name of a decision that was rendered on flammable storage tanks. And what ended up happening is when OSHA wrote the original standard, they said that there was an exemption for flammables stored in atmosphere in tanks. So if you weren't pressurizing it and you weren't trying to keep it cool through refrigeration and that kind of thing, they would give you a bit of a pass on that. Ever since OSHA wrote that, they've been trying to use their administrative means to change that because they realized that was a mistake. Because there's many solvents out there that are used in that capacity, or flammables that are used in that capacity, that are connected to a process that, quite honestly, people can point to the standard and say, well, that doesn't apply to me because I'm not pressurizing it. It's an atmospheric tank. And so the MIR decision came out around that whole thing, and it's the most recent interpretation, I think, goes back to 2018. And 2018 is still saying that OSHA was intending to reissue the standard to clarify that, but they haven't done it yet. So the decision still stands that you really aren't, if you have solvents at atmosphere on your facility connected to a process, OSHA's PSM standard does not apply to those particular tanks. But like I said, through administrative orders and other things, OSHA has kind of chipped off a lot of that variance, if you will, or that interpretation. But still, the judge ruled that they didn't write the standard very well, and they were supposed to go back and change it, and they still haven't. Yeah, it's kind of a misnomer. It was meant to help, I think, gas stations and a few other things, but it really never took off. They really put a big hole in their standard when they wrote it, and they never plugged that hole.
Thanks, Frank. Well, that brings us to the end here. It looks like all the questions are answered. Just a few final remarks. Thank you very much for attending today. As soon as we end the webinar, I'll send you an email that has a link to just a very brief 4-question survey, and would appreciate any feedback you can offer on today's webinar. We will be issuing certificates of attendance for everybody that registered for this course, and you'll get those within the next few days. And also note that this webinar, as all of our previous webinars, are posted on our website on the registration page for this webinar series. So you can view all of those there. So again, on behalf of Frank, thank you very much for attending today. I hope you have a great day.